Somewhere in the Milky Way, black holes drift silently through space. They are invisible, they emit no light, and unless something passes too close, they are almost impossible to detect. Most of them will never come anywhere near our solar system. But imagine one did. Not a supermassive black hole, but a smaller wandering one, a stellar mass black hole drifting through the galaxy, moving silently, undetected, until it was already too close. What would happen if it entered our solar system? A black hole is an object with gravity so strong that nothing can escape it, not even light. They form when massive stars collapse under their own gravity, compressing matter into an incredibly dense point. Around that point is a boundary called the event horizon. Cross it, and there is no return. But despite how dangerous they sound, black holes are not cosmic vacuum cleaners. They don't pull everything in from a distance. In fact, if the Sun were replaced by a black hole of equal mass, Earth would continue orbiting almost exactly the same way. Because gravity depends on mass, not what the object is. Now imagine a black hole passing through our solar system. At first, nothing would happen. There would be no explosion, no sudden flash of light. The sky would look completely normal. But its gravity would begin to subtly influence the outer edges of the solar system. The outer planets would feel it first. Objects in the Kuiper belt and the distant Oort cloud would begin to shift. Comets, normally locked in distant orbits, could be disturbed and sent inward. Slowly at first, then in greater numbers, a wave of long-period comets could begin heading toward the inner solar system. As the black hole moved closer, its gravitational influence would grow stronger. Planetary orbits would begin to shift. Not instantly, but noticeably. The precise balance that keeps each planet in its path around the Sun would begin to change. Some planets might be pulled slightly inward, others might drift outward. Over time, these small changes would begin to compound. Orbits could become unstable. Planets could begin interacting with each other in new ways. And in extreme cases, some planets could even be ejected entirely from the solar system, sent drifting alone into interstellar space. If the black hole passed closer to the inner solar system, the effects would become far more dramatic. Asteroids in the asteroid belt would be disturbed. Their orbits could shift unpredictably. Some would be sent on collision courses with planets, including Earth. At the same time, gravitational forces could begin to alter Earth's orbit. The distance between Earth and the Sun might change. Even small changes in that distance would affect global temperatures. But the real danger would come if the black hole passed relatively close to Earth. If a black hole passed near our planet, its gravity would begin to stretch Earth itself. This effect is known as tidal force. The side of Earth closer to the black hole would feel a stronger pull than the far side. Oceans could begin to shift dramatically. Tides would rise to extreme levels. The crust of the planet could experience stress. Earthquakes could increase. Volcanic activity could intensify. In a very close encounter, those tidal forces could become catastrophic. The planet could begin to deform. And if the black hole came close enough, Earth could be torn apart. Even if the black hole never came dangerously close, we would still see its effects. The night sky would begin to change. As light from distant stars passed near the black hole, it would bend. This effect is called gravitational lensing. Stars would appear distorted. Some might stretch into arcs, others might appear duplicated. The sky itself would look warped. It would be one of the most extraordinary sights ever seen from Earth, a visible distortion of space itself. In the most extreme case, Earth could be captured by the black hole's gravity. Our planet could be pulled away from the Sun entirely. If that happened, Earth would begin a new orbit, not around the Sun, but around the black hole. Temperatures would begin to fall, sunlight would fade, and Earth would slowly become a frozen, dark world. Or worse, it could spiral inward, crossing the event horizon. At that point, there would be no escape. The planet would be pulled apart, stretched, and ultimately destroyed. Thankfully, this scenario is incredibly unlikely. Black holes are rare, and space is unimaginably vast. The chances of one passing directly through our solar system are extremely small. But this thought experiment reveals something important. Our solar system is stable, but not unchangeable. It exists within a dynamic galaxy filled with massive objects all moving through space. And even something invisible, something that emits no light, could reshape everything we know. In the vastness of the universe, stability is never guaranteed. Sometimes all it takes is a single passing object,